Example 20 on page 561. Simplify to the form a plus bi. And this is a complex number because there are I here. A complex number can be a real number if this b equal to 0. Because b equals 0, b times I is 0. So what you got right here is a plus 0, which is a real number. Alright, so we're given this I to the 22nd power subtract 67 I squared. Now, you're asked to leave the answer as this, where I is just I, and I raised to the first power, okay? There's no I squared, no I3, or no I to the fifth power, no I to the 22nd power. You only want I, okay? You're asked to leave the answer with I. There's no I squared, no I to the third power, or any other power but I. So, we need to convert this to something, to a number, a real number, or I. So how do we do that? We know I squared. We don't know what is I22. Okay? But we do know these. Okay? Think about this as 22. You can factor this out in terms of 2 multiply something. The reason I want 2 here because the exponent we have I squared here. So think about 22. Try to factor 22 with 2 as one factor. So it turns out 2 times 11 is 22. So with that, you can rewriting this I to the 22 exponent to I squared raised to 11. Okay, so I'm replacing 2 times 11 for 22, which is here 22, right? Replacing, you know what? Let me write this maybe easier for you. So I'm replacing the 22 here with 2 times 11. Okay, and with that, I can rewriting this as I squared and then 11 outside. And we learned this in the previous sections. The reason I want to have I squared inside because I know what I squared is. Okay? So I'm rewriting this exponent in terms of 2 as one factor there. When I have that, I can rewriting this I raised to the product of 2 and 11 to I squared inside parentheses multiplied by 11. The other factor here outside the parentheses. Alright, so not only that, we know I squared, right? The outer exponents stay outside. We know what I squared is, which is -1. So replacing -1 for I squared. So we're going to simplify this. -1 raised to an odd exponent is always a negative value. Okay? Because 1 is when you raise the nth power is still 1, but this negative values, when you raise to the odd exponent, it's always be negative. Okay? Think about -1 when you square it, and this exponent is even. It will be +1. And you have -I to the 4th power when you square it. Guarantee you get +1. Okay? Or any even exponent, when you square it, any negative value will become positive. But for odd k, like to the 3rd power, when you cube it, it will equal to -1. Or when you take it to the 7th power, the result is always a negative value. So when you take odd exponent, the negative inside the parentheses always negative in the result. For even exponent, negative side will change to positive. For odd, like 3, 7, 51, 5, 51, any odd exponent, the negative side still appear in the answer. Like for this case, we have -1 raised to an odd exponent, right? Because 11 is odd. So the sign still in the result. You cannot simplify this negative with an odd exponent. So negative raised to 11 is equal to negative, and 1 you can raise to any power, it's still itself. So now we know I22, which is equal to -1. So I'll replace -1 for I22. Okay, minus 67 for I squared. We know what I squared is, which is equal to -1 right here. So I'll replace -1 here for I squared. Okay, and then simplify as much as possible. So we have here -1, negative times negative is positive 67, because negative 67 times -1 is positive 67. Now we're left with two real numbers, or like terms. You can simplify this to -1 plus 67 is 66. So it turns out the answer is a real number. For this example, there's no I involved because B is equal to 0. So example 20, the answer is 66.